Hi everyone, we are going to talk about the role of geophysics in the oil and gas industry. This is a presentation today by SP Uganda section and Turn Energy Services. So those are the details of the presenter. This is the content of what we are going to cover. We shall have an introduction to geophysics. We shall look at the applications and the benefits of geophysics. We shall also look at the geophysical survey planning, what is needed in the survey planning. We shall talk about what criteria do you use to choose which geophysical method to use, what are different geophysical methods that exist, the data acquisition, data processing, and data interpretation techniques. And lastly, we shall have a look at a conclusion about the same. So when we talk about geophysics, we are talking about the non-invasive investigation of the subsurface conditions through measuring, analyzing, and interpretation of physical fields at the Earth's surface. This geophysics usually employs physical methods at the surface, or they can be above the Earth's surface, or in the subsurface through the borehole. And in each of these, we have to measure the physical properties of the subsurface along with their anomalies, because it is usually through these anomalies that we can be in a position to draw our conclusions and do our interpretations. These physical properties which can be measured, we can talk about the dielectric, we can talk about magnetic susceptibility, we can talk about the rock or material density, we can talk about the wave velocity or speed, we can talk about the material resistivity, elastic properties, where we could talk about, and also we can talk about the material permittivity. So these geophysical methods, they can be seismic, where you have a number of them. We can have the reflection seismics, seismic refraction, the vertical seismic profiling, the VSP. It could be the ocean bottom seismics or multi-azimuth short waves if you're talking about solid particles. They could be electrical or electromagnetic methods, where you could have the electrical resistivity tomography, which we call the ERT. We can talk about electromagnetics, the ground penetrating radar for the fluid properties. And we can also talk about the potential field methods. These can include the microgravity, or what we call the gravity methods, or the gravimetry and magnetometry, plus the spontaneous potential method. Some of the applications of the geophysics is used in so they can also be applied in geoengineering. If you want to do underground water investigations, so what volume of water do you have in the subsurface, you can be in the position to use the geophysics. If you want to look at the geohazards identifications concerning the earthquakes and so on, they can be done using the geophysics. You may want to do the urban studies, and the geological mapping, archaeological investigation. Sometimes you may want to do forensic investigations. So more so the resistivity methods can be used. If you are doing civil engineering or destructive testing, it can be done using geophysics. If you want to do landfill investigations, and maybe if you want to perform, or if you want to look for unexploded ordnance detection and characterization. What are the benefits of geophysics? So these benefits So it can be used in non-destructive investigations. It can be used. So benefits of geophysics: one, it's non-destructive. Then two, it is efficient, because in terms of the results you get, it's more efficient as compared to other approaches which can be used. It's comprehensive. The results and the data that you get, it can be in position to help you draw conclusion. That's why most of the times this geophysics is used in the appraisals, because they believe that whatever you get, the data or the information you get is very comprehensive, is cost effective as compared to some. Yes, it's expensive, but a bit cost effective as compared to some other approaches like the drilling and the likes. It has been proven beyond reasonable doubt that the data that you get from geophysics it can be, it gives us valid conclusions. So how do you plan a geophysical survey? So while planning a geophysical survey, there are a number of things that have to be put into consideration. We always start by selecting and describing the target of interest. This is very important because it helps us to know what geophysical methods can be in position, or which can be applied in that on that target, or which ones cannot be applied. So how deep is the target? How wide is the target? Because some methods cannot be in position to work. Their resolution is very low at very deep locations, and others, if you're going to carry it out on a large scale, some geophysical methods may not be recommended. So that's why selection and describing the target of interest is very important. We also need to estimate the potential production costs and profits, because the underlying principle behind carrying out these geophysical surveys by service companies is to make profits. So profits is one of the things they have to put into consideration. So if you are carrying out this geophysical survey, you have to look at how much are you putting in and how much are you anticipating to get back in return. Budget acquisition costs, how much money is earmarked to be spent in the acquisition of the data. You find that if you are working on a tight budget, then it's better you use the natural fields like the magnetic or the spontaneous potential or the gravimetric. However, if the budget can allow, then that's when you can go in for seismic survey, and then you can be in position to acquire. But all that one depends on how much money is available at your disposal. Specify and document program objectives and priorities. So what are the objectives of carrying out that geophysical survey? If it is just for reconnaissance, then you realize you may not go into the details of the particular geophysical survey to be used. You may just use the ones which can be readily available. If it is for appraisal, then you have to go into more details, because there you have to be specific. Whichever reason you draw, whichever answer you give, whichever reasoning you come up with will affect the other subsequent programs or subsequent investment decisions which are going to be made. So the data quality standards. So what data quality standards are required? Do you need high quality data, or it can be maybe any kind of data? Because if it is high quality data, then you have to look for survey methods which can be in position to give you that quality and accurate results. Then setting reasonable schedules and deadlines. For how long is the survey going to take place? Because some surveys require a lot of time, when others they can be achieved in as less period of time as possible. So you have to put that into consideration. Then after that, that's when you have to select which geophysical methods you are going to use and which equipment for each of those particular geophysical method is going to be used. So in our next lecture, we shall talk about the why or what consideration do you put in mind before choosing which geophysical method that you're going to use. Thank you for listening.